Today, we'll discuss a virtual business simulation model of a printing shop with Simio. I am Askar Chaudhary, professor at the College of Business. This case study was presented to McLean County Chamber of Commerce Manufacturing Council on May 17, 2022. This is about a small printing shop owned by Mr. Tom Mercer on Veterans Parkway, which has 3 workstations, and there are 4 types of jobs that goes through those workstations. Not all jobs needs to go through all workstations, and they go to each station through a circular path. All jobs goes through jobs arrival station, then they go to station A, then station B, and then station C. So once a job needs to go through station A and station B only, exit from the system in here. If a job needs to go to station C, then after it gets done, then it will go back and go through station A and station B and get out from the system. Station A has capacity of 1 machine. Station B has capacity of 2 machines. Station C has capacity of 2 workers in the morning and 1 worker in the afternoon, and they are human workers. Station A needs 2 to 8 minutes of processing time. Most of the time it was 5 minutes. Station B needs 5 to 11 minutes, 9 minutes most likely, and station C 2 to 11 minutes and 6 minutes most likely. Station A also breaks down the machine every 3 hours on average, and the repair time is 30 minutes. Station C has a meal break in the middle of the day for half an hour. So when nobody is working in station C, it is empty, and in Simio you will see that the color turns to white, implying empty. And in station A, when machine breaks down, the color will turn to red, implying that machine has breakdown. Mr. Marshall is interested to know the efficiency, how efficient the system is. So in that respect, he wants to know how long jobs are waiting before it gets processed, how many jobs are waiting in line in front of the stations before it gets processed. Is there any bottleneck? If there is a bottleneck, how do we resolve it? If this shop provides service to customers while individuals are waiting in the waiting area, how large the waiting area should be. To answer this question, we will develop a model in Simio. Before we go into the Simio, couple of other things is the job sequence is similar to this table. So this table provides the job sequence. For example, job 1 needs to go through station A and station C only, and job 2 needs to go through station A, B, and C. And therefore, we can make the job assignment for station A. We'll see only job 1, 2, and 3, and station B will see only job 2, 3, and 4, and so on. Jobs are color coded. Job 1 will color coded to green, and job 2's color is red, job 3 is blue, and job 4 is yellow. So when they go to these stations, we can identify which jobs are there and how many of them. So this is basically a screenshot of Simio model that we are going to go to in a second. Once we run the Simio model, then we'll discuss the results. So if you run the Simio, we'll see in station A, we'll see only job 1, job 2, and job 3. So now jobs are coming in to this point, and they will go into this direction only and get distributed where they're supposed to be. As you can see, station A has green, blue, and red. Green, blue, and red. And station B should have red, blue, and yellow. So they have yellow now. Station C will have green, red, and yellow. So we have green and yellow now. So you can see station B has red, yellow, and blue, which are these. Now we can also replace these objects in Simio and replace them with the three-dimensional objects. And we are going to do that now. So now this is job 1, job 2, job 3, and job 4. And they are replaced by something that looks like books for printing shop. And these jobs will come through these conveyor belts and proceed through these stations only in this direction. And we'll get the processing done. So this is where the jobs will be sitting when they're getting the processing done. And then this is where the jobs will be sitting outside the station waiting to get the job done. And this is where we'll see the bottleneck. When we have bottlenecks, we can resolve this issue by increasing the capacity. So in this example, we'll increase the capacity and see how the results changes. So let's run it. As you can see, jobs are coming in and getting distributed. When the job is done, they will get out from the system to the exit station. And I can speed it up, and then you can see it's going into circular path and getting out from the system. Now I can fast forward and finish up the simulation. As you can see, there's a long line in this station. So at this point, we added one more machine in this station to reduce the job load of station A. So I would like to look at the results. The results are here, and we are going to look at the results from a table. I put them in a tabular format to make it easy to discuss. We can look at this also by rotating the view, so that will give us a picture from all different directions. And also we can zoom in and zoom out and move the view the way we want to see it. So let's go to the table and discuss the results. So we have three stations, A, B, and C, and capacities of those stations stay same except for station A. We increase the capacity to 2 machines to reduce the bottleneck. So as we saw before, there was a bottleneck in station A. Station A utilization went up, and the average number of jobs that are waiting outside the processing center was about 38 jobs sitting in line to get the job done. And each job on average was waiting for about 4 hours. When we added the second machine, which we call scenario 2, the utilization went down and the number of jobs waiting outside the station went down from 38 jobs to 2 jobs only. A bit of improvement in terms of efficiency, and in terms of waiting in line, it went down to 12 minutes from 4 hours. So that was really needed to reduce the bottleneck. However, this also impacted the other stations. So station B utilization went up because a lot of jobs now are done quickly by station A. So station B and station C's workload has increased a little bit. So it went from 78 to 83 for B and 73 to 80% for C. And in terms of number of jobs, it just increased a little bit from 1.5 to 3 jobs in station B, and station C about 5 to 6 jobs in 1 job increase. And the time is also Not too bad. From 8 minutes, now it jobs that are waiting in line is 16 minutes. And here efficiency 27 minutes to 30 minutes. So it appears that the solution to reduce the bottleneck and increase the efficiency is by using one more machine for station A. Also, total number of output has increased almost 50 units. So we are producing more units, thus productivity is going up by adding one more machine.